Okay, so I have made the Sieve of Eratosthenes. I think it is called. I think it's called. Um, but it works pretty well. It's pretty fast. Um, when you first start it, if you have a really high number, like 400 billion, it for the limit, it takes a really long time to get the first couple um, like passes, the first couple numbers, which I'll explain in a second. Um, but it's exponentially the progress is exponential, which is really cool. But basically, oh, this is written in Rust, by the way. I've been learning Rust and I've been implementing little like small projects. But basically, how this works is it loads a it loads a so in Rust, it's really hard to have, or I guess it's not hard, but like it's annoying to have vectors or arrays of individual bits because usually you can only have bytes. So there's a crate called bitvec, which allows you to have a vector of individual bits. It saves memory by eight. It saves 8 times as much memory, because it's 8 times as small because it's a bit instead of a byte. So you have a list of numbers. I guess it's not a list of numbers. It's a list of bools, basically, as bits. And the value here basically says if it's on or off. So if it's a prime or not a prime. And by default, they're all primes. It says they're all primes. And then the current prime is 2 because 1 and 0 are not prime. And this is setting 1 to not a prime. And so it starts here. It gets the start time to show you how long it took. And then it starts at 2. And then it says 4j in the current prime times 2 to the limit, and then you step by the current prime. And so what this does is it multiplies this value until it gets, oh wait, that's, I think this is wrong, because it should oh wait, no, I'm dumb. Okay, never mind. So this is right. So basically, it starts at times 2, because how the Sieve of Eratosthenes works is it starts at 2, and then it basically every multiple of 2 it marks off, because if a number is a multiple of another number besides 1, then it is not prime, and so you can mark them all as false. And so you start as this one, and then you step by the current prime. So basically you're stepping through all of the multiples of this prime, and until you get to the end, because you don't need to go past that. And this is just setting all of them to false. And then you add 1 to the current prime, and then it checks if, so this just goes to the next number, but if the next number is not a prime, then you don't need to do this part. And so then you just keep adding 1 to the prime until it does that. And so then you get to this part, which basically, because printing is slow, I made this number here is just, it checks if I is a multiple of that, and then it prints. So it only prints the percentage of the way through it is occasionally, just to save on speed. And then because it never actually completely finishes, I just made it say 100% right here, just because it looks better instead of being like 99.999. And then it says the time it took to calculate the primes right here, and then it gets the new start time for writing to the disk, which it basically, what this does is it goes through all the primes, all the numbers, and it checks if this is a prime or not. If it is a prime, then write it down to a file, append it as like a new line, and then write that down. And this also is the same thing, where it just every couple intervals it prints to the screen, or the progress of it. And the write counter is way lower. It's a lower interval to print because it's it's a lot faster to write to the disk. And this is just looking at good again. And then it tells you how long it took to write. And I have done this for OBS. I couldn't get OBS to stream my screen, but I have done it for I'm going through my documents right now, but I have a list of them. Yeah, here we go. I have primes up to 10, 100, 200, 1,000, 2,000, 2 million, 10 million, 100 million, a billion, 2 billion, 5 billion, 10 billion, 120. What is this? It's this is, oh, sorry, that was 100 million, 200 million, 500 million, a billion, 12 billion, 25 billion, 50 billion, 100 billion, and right now I am working on 400 billion, which is taking forever. It's been, I think, 2 hours so far, and it still hasn't passed this interval right here to print. It hasn't printed anything yet, but I guess I'll just have to wait. And because I'm using a stock cooler right now for my CPU, and it's not very good, and so I have my air conditioner. So my PC case is open. I have the front off, and my air conditioner, it's one of the movable ones. You can move it around. It's pointed directly into my PC case, and it's very cold. It is 35°C right now, which is, if I didn't have my air conditioner on it, it would be around maybe 100, I think. So it really helps. It's kind of stupid, but it works really well. Oh yeah, so the 100 billion, the primes up to 100 billion, it's the file size of that is 48.9 gigabytes, and there are a lot of primes that go here. So I'm pretty sure there's, yeah, it's 4,118,054,813 primes from 0 to 100 billion. So that's pretty cool. The reason, besides speed, the reason I haven't gone past 400 billion is because I don't have enough memory on my computer. Because 400 billion bits, 400 bits to gigabytes. 400 billion bits is 50 gigabytes. So that takes up 50 gigabytes of RAM. And I have 64, so I can afford that. But anything over that is way too much. I can't, it won't work. Because if it tries to allocate that much memory, it fails. Because there's not enough. So it is kind of sad, but also I feel like it would take way too long to do that anyways. But, you know, I'll try to... There might be other algorithms I haven't found yet, or just other improvements that I can find. But if I do, I'll put an update about that. And I guess my website's broken right now, but once I get it up, I guess I can probably host the prime files. I don't know if anyone would want them, but like the lists of primes. You can probably find them on other sources, but, you know, just comment if you want to look at them. But yeah, this is the code. I think it's decent for like my first couple like Rust programs. I think it's pretty good. But yeah, that's my prime generator.